Hi everyone, welcome to this lesson. So as we know, I'll be discussing the chapter 2 of my book, Multi-Agent Orchestration Pattern for Enterprise Scale System. And today we'll be looking at the content, summary of the content of what we have in chapter 2, which talks about agent communication and coordination protocols. So we'll dive deep into the content. We'll look at the highlights, but do well to buy the book to see the breakdown of how agents communicate and the best practices when you are designing a multi-agent system. How should you design your agent to communicate? And when you are building for large-scale enterprise, how should you design the agentic communication system? So that's what we want to discuss in this chapter. So agent communication and coordination protocol is what we have as a topic. And of course, we know that agent communication encompasses structured and coordinated agentic interactions that enable the agent or the multi-agent system to solve complex problems. So this interaction is very, very important for agents to coordinate well, to work together and solve problems without any faulty interaction or without giving an error outcome. So we'll be looking at intercommunication fundamentals and everything. So connecting the tissue of multi-agent system through patterns, transport mechanism, and using a protocol. So this is what we have in slide 1, inter-agent communication, which is just the content of what we have in section 2.1 of the book. So inter-agent communication fundamental. What separates systems that work in production from systems that work in demos? How can you differentiate them? How do you build a performance agent? How do you follow best practice for agentic communication system? How do you ensure that your agent can communicate properly when you have them, when you have them many, when you have up to like 5 of them, or 10 or 50 or 40 thereabout. So good message makes or a good message makes agents to work together very well. Good message makes agents to be auditable. It makes agent communication to be traceable. It makes them to be routable, and it makes them to be debuggable, so that if you have error, you will know exactly where the error is coming from. So communication model. So you can use, of course, we have the communication model, we have the pattern. So communication patterns determining whether agents form a coherent team or a chaotic crowd. So when you design a pattern, the pattern that you design for the agents to communicate will determine whether you have a structured agentic workflow or a structured multi-agent platform, or you just build a chaotic crowd for an enterprise. Transport mechanism. The connective tissue across supply chain, procurement, legal and IT domains. Transport mechanism is very, very important. Do you want them to be synchronous or asynchronous? You want it to be event driven. So all these are very, very important requirements that you must put into consideration when you are designing agentic system. Also, we have concrete requirements, balancing latency tolerance, consistency needs, and regulatory constraints. So these are the 3 principles. Concrete requirement is also very, very important. You must be able to balance how the agents should tolerate each other. You must be able to balance the consistency of communication between the agents. You must be, you must also design with regulatory constraint in mind. How do you make sure your agents do not bypass policy while talking to each other or while sending messages to each other? So the interaction pattern we have a request response, as we have in the book. So please do buy a copy and study. We have proposal, we have agreement, we have failure message, we have notification pattern. This is our pattern. request response pattern, notification pattern, approval requests, status update, we have proposal pattern, we have agreement, we have failure message. So it's all in the book, very clear and stated with code guide. Please do well to study it. All right, so let's go to content 2.2, where we have message or message transport and routing mechanisms. So that's what we have as a content of section 2.2. So a message needs to reach the right agent. It must carry context and be auditable across. So you must make sure the message is auditable. You must make sure the message is traceable. You must make sure the message is reliable. So because if the message is not traceable, you will not know which agent is sending which message. So and it's going to cause error in the system. So therefore, this is why in the signing multi-agent system mass, you must consider the following field and for the following purposes. Okay, so you must make sure you put sender ID, assign sender ID to each agent. Make sure each agent has sender ID. Make sure they have receiver ID. Make sure you define message type. Make sure you define correlation ID. Make sure you define conversation ID. Make sure you define the priority of the message and the time to leave in seconds of the message. So sender ID is or is meant to identify who sent the message. So if you have sender ID in your design pattern, you'll be able to know which agent is sending which message and to who is receiving it. So receiver ID allow you to identify the agent receiving the message. Message type, it allow you to also identify the type of message that is being sent. Is it task request? Is it status update? Is it approval request? So make sure sender ID, receiver ID, message type are properly defined in your design. Then correlation ID. These links reply to original request for sorting. So correlation ID allow you to link, a message to receiver and to the sender. So it's align them together and make sure they correlate. They are closely related. Then conversation ID. This groups related messages across multi-turns workflow. So conversation ID allow you to identify the conversation between two or more agents. Okay, you have the sign correlation ID. You know which message type correlate to which sender and to the receiver. Then conversation ID, the entire conversation between the two or more agents is being identified using conversation ID. Then we have priority. So priority is designed for the purpose of operational hint where 1 is highest and 10 is lowest. So make sure you give your message to priority. And then you know which age or message is more important and which one is less important in the workflow. Then time to leave in second. So this enables the agent to discard or enable messages to be discarded after this many seconds of undelivered. So when a particular agent sends messages several times and it is undelivered, then time to leave enables the system to delete the message because it is not relevant and it is not delivered. So instead of storing the message in the system while overloading the system and causing memory downtime, it is better to design time to leave and get the agent or the message deleted when it is not delivered. So that is the content we have in section 2.2, guys. And now let's move to section 3.3, which is agent communication language and standard, which I stated as three communication models here. So the choice of model reflects the relationship between sender and receiver. So the model you are using actually determine how the sender will relate with the receiver. Okay, and then we have four models here or four design pattern for multi-agent communication system. The first one is point to point, which encodes a direct dependency where agent A knows agent B exists and needs something. So because let's say my name is Funke now. I have a sister named Tayo. So let's say if she needs something, I can identify her as Tayo and then I can give her what she needs. So if agent can identify each other as needing a message through their conversation ID or through their sender and receiver ID, then the agent will know which agent to send message to so that there will not be confusion in the system. Okay, so agent A knows the receiver of its message. So it sends directly to the message to the agent ID, and the agent B receives the message through agent A's message ID, which is the sender ID. So it should be point to point. So that is one of the first design pattern. The next one is broadcast. So here, you don't have a particular agent that is assigned to a particular message. So one agent just broadcasts or just announce a message, and any agent that is, designed for that to solve that problem receives and carry on with the message, and that is how it works. So encodes urgency and universality. Everyone in the system should know about this fact. So broadcast does not have a particular receiver. One particular agent just sent message, and agent Q or receive the message and interact with it, or if they cannot solve it, they pass it, they broadcast again, and then another agent receives it and works with it. Then pattern 3 or model 3, we have publish subscribe. So this is event driven. It uses PubSub or event on Azure or Azure Service Bus or Service Bus or RabbitMQ or Kafka to publish and subscribe. So encode loose coupling where the sender publishes a fact and subscribers decide relevance. So one agent, which is the subscriber, publishes information, then the subscriber agent decide whether it is relevant to it and then act on it. Then we have pattern 4. Pattern 4 is inspiring heading. So publish subscribe lets you add a new agent, a compliance check, or risk monitor without changing existing code. So point-to-point calls need surgery for each new capability. So this builds on publish subscriber agent as well, and it lets you add new agent, okay, a compliance check or risk monitor without changing existing code. So you can add new agent to an existing agent, you can add new pattern to an existing pattern, and then you can even redesign the code without affecting what you have at hand. So this also improves performance. Then let's look at what we have here, which is routing. So how do you design routing? How does agent route messages to each other? So the sending agent doesn't need to know who handles what. The routing layer decides. So the router in the system design decide, which agent receives what, so that agent doesn't need to know who handles what. So the router routes the message to the right agent, and the right agent receives and acts on it. That is another design pattern. So what does this how does this follow best practices in design? So this enables high value review. That is, when you have contract above $500,000, always go to senior legal review. That is the work of router. It's with design the particular route and route to a particular agent. It will know that, okay, whenever you are designing a procurement agent and you have a contract agent who receives this, you have a legal agent who also receives. So you know that you have designed that, okay, whenever you have a contract that is above 500,000, the router will automatically route to legal agent, not the contract analysis agent. That is how it works. Then we have another design, which is risk mitigation. Any request with supplier is risk flag, goes to compliance first. So whenever there is a direct request from supplier, the router will flag it as risk, and it must pass through compliance. So if the request from the supplier aligns with the policy that has been defined in the agentic system, then it will now come back and be routed to, the agents that can handle it. So it enables the system to also withstand risk. Then we have IT op change. So here, production infrastructure request go to the change advisory. So you are designing IT ops, the router routes any infrastructure request to the change advisory before before any other agent can undo it. So it is routed to a specialist agent, which is a change advisory board, and it is assigned priority 7 in the book. You can check the book and study more on this designs. Then we have default route. Everything else goes to the general orchestrator. So that is the default route, where if it is a general message, then it goes to the general orchestrator. The general orchestrator determines which agent to send it to, and then the message goes to the particular agent. And then we have the supply chain routing. So semantic routing can dispatch port closure event to inventory, procurement, and finance without the monitor knowing. So that is supply chain routing. It handle specific dispatch of goods, closure of events to inventory, and procurement of operation and finance without the monitor knowing. And it's designed for that purpose, and it work for that purpose only. So these are content-based routing. Now we have agent communication language and standard. So what language does agent use to communicate? Of course, we know everything is coded using Python and everything. So what are the standard of communication in agentic system design? The first one is FIPA ACL, or FIPA ACL. So it uses performative languages, that is speech acts, like request, agree, inform, and failure to communicate. So it uses normal, human speech format. Acts as if it is speaking, they act as if they are speaking to each other. So one agent make a request to another agent, the agent agree, and the agent inform another agent, and then whenever there is failure to communicate, the agent gets back to the initial agent that sent the message. So that is FIPA-ACL. Those are performative. They use performative languages. Then we have performative in full. So this establishes shared semantics. So agents don't have to guess if a message is a notice or a demand. So this allow the agentic system to send structured specialized or personalized message to a particular agent. So the agent sending the message, we know that this whole message that I'm sending belong to this particular agent, and the agent or the message is directed to the particular agent. That is, semantics means structured and specialized message that is meant for a particular person or an agent. Then we have agent-to-agent communication as well. So in agent-to-agent standardized agent discovery, capability, advertisement, and negotiation via agent card. So this design uses standardized agent discovery. Agent A can discover agent B and send message to agent B. Agent A can discover agent C and send message to agent C. Agent A can discover agent F and send message and communicate directly with agent F. So that is agent to agent communication, which is also a very strong design pattern that is still, still cooking. Yeah. Agent card. We have machine readable JSON document, open API for agent, listing identity capabilities, and SLAs. So agent cards are like JSON documents designed for particular agents. Listing identity, it lists the capabilities and the service level agreement. This is just like, let's just say this is like the skills that we are now designing these days. So instead of building multiple agents, you just design agent card. You build skills and then you feed it into your agent. You understand? Or self-documenting, a log of informed requests and refused messages tells a clear story without needing to decode proprietary format. So agents are able to self-document their information, who they are sending to, what they sent at a particular time, and at the time that they send the message. So it enables them to keep log of information, log of information they sent, log of requests that they receive, and log of refuse messages, uh, so that they can tell clear story without needing to decode proprietary formats. So these are the agent communication languages and standards that we have in the book. Now the next one we have is synchronous and asynchronous design. So synchronous and asynchronous pattern. The decision affects latency, throughput, resilience, and debugging complexity. So synchronous, we have a send message without blocking, send message and the message can be blocked. We have asynchronous, event-driven, non-blocking. Okay. So this pattern, what are they and how are they important? So asynchronous is a kind of simple message. It's a very simple design pattern. A message go to agent B and the message can be blocked. But for asynchronous, it is more complex and it is more capable than synchronous or agentic design. So synchronous system are simple, easy, but block sender. Okay, it blocks the sender. Asynchronous design pattern are complex, capable, continuous operation, and uses correlation ID. Okay, so you can link a message to the sender and to the receiver. So that is why they are very, very important. So let's look at how this system work. Pattern. Agent A wait for agent A for pattern. In synchronous design pattern, agent A wait for agent B. So when agent A sends a message to agent B, agent A will wait for agent B to receive and process the message before moving on. So that means if agent B refuses to acknowledge the message or to act on the message, agent A will continue waiting. You understand? But for asynchronous design pattern, agent A publishes and moves on. So he doesn't wait, he doesn't look back, he doesn't wait for any request. It just publishes to agent B and then move on with its own activity. Complexity. Synchronous agentic design pattern or synchronous communication pattern are very easy and traceable because agent A will not continue until agent B receives and processes the information. So, or why asynchronous are harder to write and debug because you don't know or you don't know which agent has failed. Agent A has publishes and moves on. So for you to discover which agent receives, whether the message is delivered, and whether the message was acted upon by another agent. So that will cause it's harder to debug if it is not properly designed. Scalability. Synchronous communication design pattern is limited by resource blocking because, of course, one agent will not continue until it knows that the message is received and acted upon. So it causes resource block. So if it takes 5 days for agent B to receive and act on the message, the system will be stagnant for that 5 days and keeps on waiting. Then for asynchronous, scalability comes naturally. Natural, concurrent, and scalable. Naturally, they are scalable. There is no wait. It is event-driven and continuous. Failure creates latency chains. So there is no latency, very slow, and can be stagnant for days. But for asynchronous, we have this coupled via queues and broker. We have service broker that allow distribution of the message. We have we have queues that allow the message to go or sequentially one after the other. That is when a message is delivered, it is wiped out from the system and it is considered as gone. Use cases. Synchronous communication design pattern is good for human waiting at a browser. So when you are designing for this kind of problem, you can use synchronous. Then asynchronous is used for high volume enterprise workflow. So here, when you are designing multi-agent system for an enterprise, you should consider using asynchronous communication. So in an async pattern, procurement agent elapsed time is microsecond to publish. 10 other contract reviews can be in flight simultaneously, while the legal reviews complete at their own pace. So this is how the synchronous and asynchronous communication patterns work. Please read more in the book. It is in section 2.4. Event-driven architecture, that is section 2.5. So how do you design for event-driven a multi-agent system? So instead of one agent, controlling, instead of one agent controlling the system, excuse me, agent publish facts and other agent decide whether to react. Okay, so there is no waiting. The system is continuous and event driven. So publish and subscribe. One agent publish, and many agent queue for it, and the right agent receives and act on it. Okay, so three message type here that we have here. We have commands, we have events, and we have queries. So these are what we have here. These are the three message type that we have here. Command, that is instructions to a specific agent, e.g., suspend vendor, reject a particular contract, or and so on and so forth. So there is a particular message, and it's the agent just issue a command, and the receiver receive it and act on it immediately. Then we have another one, which is events. So facts about what has already happened, name in past tense. So events are, just like what is kept in episodic memory, what has happened before, what has been done before when a particular situation. Remember that this agent also learn. They learn from past, what is done well in the past, and they also learn from past mistakes to improve themselves. So e.g., maybe in the past, when a command was issued, suspend vendor, vendor is suspended, then that becomes event. So whenever there is suspend vendor, event automatically carries it as vendor is suspended. Then we have queries design pattern. In query, request for the current state of information. So query is just like designing for request for the current state of information. You want to know the current state of information in the system, then you use query design pattern. So autonomous publisher do not know all subscribers. Take note, in event driven, the publisher do not know all the subscribers. So event sourcing support audit, compliance, and debugging. So event sourcing, storing the queue of events rather than just the current state for complete audit history. It is auditable, very, very auditable, very, very auditable, and it supports legal compliance and defined policy in the system. So it proves that the system knew when it approved a purchase order, the system knew when a vendor is suspended, and the system also knew that what was done at the actual, what was done in a particular time, and the event log of the system, and the event log that was not reported. So the system knows everything. So we have the next chapter, guys, which is 2.6, where we discuss message broker and event buses. So of course, if you're a data engineer or system engineer or software engineer in the house, you will have used this framework or platform. So Kafka is used for event streaming. In data engineering, we use it for streaming data. So publisher and receiver, and it's allowed, near real time data streaming as well. So this is also the design pattern we follow here. Remember, agentic engineering built on data engineering. RabbitMQ, which is standard standard event bus or standard message bus for sending messages, and then we have NATs. This is particularly used in networking or network infrastructure. So the broker is the infrastructure that makes agent coordination work as stale. Broker is very, very important, very, very important. Event broker. So there must be broker that will break topics into messages, and then the messages are published and the subscribers are able to subscribe and receive the message. So in Apache Kafka, we have replay, we have durability, and event ordering. It is very, very ordered, very, very ordered. So Apache Kafka is a distributed system that is near for real-time or near real-time operations. So a distributed commit log built for replayability. If an agent goes offline, it can read every event it makes in order. So it allows when the message is published, even if the agent is offline, it can still come back and read all the messages that are in queue for it in order and act on it. Then we have RabbitMQ. RabbitMQ allows routing. So it makes routing very, very flexible. It makes routing messages very flexible. It's a sophisticated routing engine using exchanges and binding rules. Okay, so best when routing logic is complex and volume is moderate. Very, 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 very good for uh, message routing. Then we have NATs. NATs is built for speed and scalability. Real-time IT it's built for real-time IT operations. Why current state also matters more than hold event replay. So NATs are particularly used for IT operations and networking. It is built for speed, and it works in sub-millisecond latency. ID for IT operations where old CPU, like a CPU spike from 3 minutes ago, are worthless. So that is what it's used for. It's also event driven. Then we have recommendation. So when you are designing multi-agent system, start with RabbitMQ for your first production deployment. Okay, so later you can scale to Apache Kafka, which is more robust and can add late arriving messages. It is easier to operate and provide routing flexibility as workflow evolve. Then we have the section 2.7, which is where we have security and reliability. So how do you ensure that multi-agent communication patterns are secure and reliable? 3 patterns working in concert to prevent cascade failures and unauthorized access. So the first one we have here is, retry with exponential backup. Retry with exponential backup. So it uses jitter to spread out retries and avoid thundering head problems. That is what it is used for in that place. Please read more about this in section 2.8. We also have circuit breaker. Circuit breaker allow trips. In circuit breaker, you have trips after consecutive failures to immediately reject requests and prevent system stalls. So this allows prevention of system stalls in design pattern. Then we also have the dead letter queues, which is the third reliability pattern for security and reliability. So dead letter queue captures malformed or failed messages for manual inspection and compliance. So when dead letter queues are malformed messages or failed messages, which are stored in a log and can be analyzed by human in the loop to know the cause of the problem. Then we have, in terms of security, we have layered security. So you design for layered security in your system, combine transport, encryption, MTLS, agent identity, JWT, and role-based access control together to know so that it will limit the agents to what they can access, what they can it enable you to identify the agent, it enable them to also authenticate to an application, before using the application, and then make sure the messages are encrypted, both from the sender and from the receiver, end to end. Then we have record messages, record message IDs. So just as we have discussed earlier, we talked about having the assigning identity to whatever is going on within agent, including the agent itself, so that you know what is happening, the message type being sent, who sent the message, and who received the message. So make sure you also have message type and message ID. Without observability, security and reliability will fail. So observability is not just monitoring and keeping log. It is analyzing the log, checking for metrics to determine what is failing and what is succeeding in your system. So in observability, you keep logs, you keep metrics, you keep traces of the message, you keep logs of message, you know, determine the metrics of the message, late arriving, receiver, time it was received, and time it was sent, when it was processed, and when it was delivered. So those are the metric are numerical observation of a system. Then you also keep traces. So traces how the agent moves through your correlation ID. Then you also keep or audit the record. Okay, so record every process message ID to stop tampering and duplicates. Very, very important. So, and that is section 8. So, communication orchestration guide for enterprise multi-agent system is what is discussed in all chapter 2, and it is very, very interesting. And then guys, I have put this architecture together so that when you are designing your pattern, your communication flow in your multi-agent system, you can follow it, and then you know follow the security and best practices, reliability, and ensure that you are building a reliable multi-agent system. So here we have the first part here, producer sender layer. So we have the producer and the sender layer, and then we have the message envelope layer, and then we have the consumer and the receiver layer. So in producer or the sender layer, you have the user and the system events. You have the orchestrator. You have the agent A, agent B. So agent A, agent B can be the sender, okay, and they can send events. Orchestrator can send events. So these are the sender, and these are the possible sender. Orchestrator, agent, and user or system can send message. Then we have the message envelope. So remember, we said that when you are designing agent, you should design for identification. Make sure you have task ID, workflow ID, trace ID, message type, payload, receiver ID. That is the agent IDs now. You have receiver ID, you have sender ID, you have your message type, you have the correlation ID, everything that will allow you to, trace the message, trace and observe the message. Then this is passed down to message bus or event broker like RabbitMQ, Kafka, or NAT for IT operations. And then the messages, the information are queues, and they are defined into topics, and then they are routed, and then they are published. So after that, we have when they are published, you have the receiver layer. When a message is published, you have the consumer or the receiver layer. So specialist agent can receive the message. The message can be sent to tools. Services can receive the message. Workflow handlers can also receive the message. Human review queue or human in the loop can also receive the message. And all these platforms are built on reliability and security. Make sure everything you are designing is traceable, auditable. Make sure you implement role-based access control, authorization using JWT, or any cloud platform that you are using like Microsoft Entra ID. So make sure you implement retries for late arriving messages. Make sure you implement dead letter queue for failed or unuseful messages. Make sure you design correlation ID between messages. Make sure you also design MTLS and OAuth 2, for authentication and authorization, and make sure you keep logs of all the, message and information pattern in the system, so you can analyze and observe the system. And all this is decoupled. So this is, the foundation of decoupled communication, decoupled coordination, traceable message. You have a decoupled coordination, you have traceable messages, you have a resilient workflow, and you have secure agentic communication. And thereby, you are building a reliable multi-agent orchestration pattern. So why this matters? Why is it important to follow this design pattern, a multi-agent communication pattern? It is important because synchronous plus asynchronous communication, it allows you to differentiate between when a message should be synchronous and when it should be asynchronous. When should agent communicate synchronously and when should agent communicate asynchronously? And it also allows you to know that your system is reliable, event-driven, and coordinated. So it enables you to build reliable, event-driven, and coordinated system. Then it allows your system to be debuggable in production workflow. So this is why communication design pattern. So this is chapter 2 in a nutshell. Or get a book and read more. You see the coding, everything coded. You can follow the design, the guide in the code. I will also drop the link to the code repository. The link to the code repository is also in the textbook. Thank you guys for listening. See you in the next lesson.